So this is the third part of our 8.2 notes. I ended up doing it in 3 parts anyway, even though I said I wouldn't. So this is the story problem and also the section where we have to find the zeros of a function. So this is our position function, f of t equals negative t squared plus s of 0. Remember, negative 16 has to do with gravity. This is always going to be the same, and it's negative because gravity pulls things down, and s of 0 represents the initial height, where we started at. So an egg is dropped from a height of 64 feet. That means my original function has a y-intercept of 64. So I graphed it on Desmos. You see where it crosses the y-axis at 64. Now this part of the parabola isn't going to help me with my story problem because this would be negative time. So we're really only looking at this half of the parabola. And the question is, after how many seconds does the egg hit the ground? Well, when it hits the ground, what is the distance? Oh. Hitting the ground means the distance is 0. In other words, we want to know what is the 0 of the function. So at this point, because the y-coordinate is the height or the position, so see here the height is 0. So that would mean it hits the ground after 2 seconds, or I shouldn't say after, at 2 seconds because it's exact. Now, what would happen if we change the initial height? So what's going to happen if we move up a certain number of units or move down a certain number of units? So I'm going to go back to Desmos. All right, so I'm going to use x. F of x equals negative 16x squared plus 64 plus k. All right, now I'm going to make my screen smaller so we can see it. Okay, I'm going to pause. All right, so here's the original function, all right, starting at 64, and then it hits the ground at 2 seconds. What's going to happen if k is greater than 0? What happens to where it hits the axis? Do you see that? The higher the graph, the longer it's going to take to hit the ground. So if k is greater than 0, it's going to take more than 2 seconds. So what do you think is going to happen when k is less than 0? So let's go the other way. Let's say we go down to a little over 50. How many seconds will it be before it hits the ground? Oh, do you see? It's less than 2. Okay? So how do we stop? How do we say that here? Well, this is how we say it. When k is positive or greater than 0, that's another way to say positive, the egg will take more than 2 seconds to hit the ground. When k is less than 0, the egg takes less than 2 seconds to hit the ground. Okay, you can pause there if you need to. Now the new thing I added was just a quick reminder of how do you find the zeros of the function. So this goes with problems 19 through 26, okay? One way is to set the function equal to 0 and then factor like we did in previous problems. Okay, I see that there's a GCF of 4, so I'm going to divide everything by 4 to try to simplify this. And then maybe I recognize, hopefully you recognize this is a set of identical twins, or fraternal twins, sorry. So this becomes x plus 2, x minus 2. And then the next step is to set each of these equal to 0. So my two solutions are -2 and +2. Now this is not a story problem, so in this case both answers will be right. There is another way to do this that we'll learn in Algebra 2, but we'll stop right there on that factoring part. Another method, which is completely viable, is to graph it on Desmos and find the x-intercepts. So there you go. The only problem with this is if your answer is a decimal and the book wants a whole number answer. So then you might be stuck factoring. But you can just graph it on Desmos and look for the x-intercepts. All right, so there you go. That's 8.2.